Hello everyone, today our topic shall be Raoult's law. So from Raoult's law we have PA is equal to PA not XA. So Raoult's law is a topic from a chapter solution. So from Raoult's law we shall learn how to find lowering in vapor pressure. It is relative lowering in vapor pressure. We can find vapor pressure of a solution, vapor pressure of a pure solvent, and mole fraction of a solvent. We can also find molar mass of a solute and solvent, weight of solute and solvent. So according to Raoult's law we have PA is equal to PA naught XA, where PA is equal to vapor pressure of a solution, where PA is equal to vapor pressure of a solution, PA naught is equal to vapor pressure of a pure solvent, and XA is the mole fraction. Mole fraction of a solvent. Mole fraction of a solvent. So these are the terms. So PA is your vapor pressure of a solution, PA naught vapor pressure of a pure solvent, and XA is mole fraction of a solvent. So using this we shall learn how to solve some problems. So the first question we have: the vapor pressure of ethyl alcohol at 298 Kelvin is, so the vapor pressure of ethyl alcohol at 298 Kelvin is 40 millimeter of mercury. Its mole fraction in a solution with methyl alcohol is 0.80. What is its vapor pressure in solution? So from the first question we can know, let's write the given. So what is the question asking you? What is its vapor pressure in solution? So vapor pressure of solution is PA. So I'll just put question mark out here. So the vapor pressure of ethyl alcohol is a solvent, at 298 Kelvin is 40 millimeter mercury. So you have PA naught is equal to 40 mm of Hg. Its mole fraction in a solution with methyl alcohol is, so its mole fraction is XA, we have 0.80. So they have given you PA naught and XA. So using this formula we shall learn how to find vapor pressure of solution when they have given you vapor pressure of a pure solvent and vapor pressure of a the mole fraction of a solvent. So putting the formulas, we have PA is equal to PA naught XA. So we have PA is 40 multiplied by 0.80. So if I multiply 40 with 32, so I shall have 32 millimeter of mercury. So this will be your vapor pressure of solution. So the question is very easy. So they have just asking you what is vapor pressure in solution if it's mixture of a Raoult's law. So out here I'm not telling you how to derive the equation out here, and I'm not going to explain how to derive the equation. I'm just here to help you with the problems. So before we start the second question, we have out here, I'll just write the term PA naught minus PA divided by PA naught. This is known as relative lowering of vapor pressure. So I'll just write Vp. So Pa naught minus Pa by Pa naught is known as relative lowering of vapor pressure, and also Pa naught minus Pa is known as lowering of vapor pressure. So these are the two terms you need to know. Pa naught minus Pa divided by Pa naught is relative lowering of vapor pressure, and Pa minus Pa, Pa naught minus Pa is known as lowering of vapor pressure. So now we will solve the next questions. So we have vapor pressure of water at 20 degrees Celsius is 17.5 millimeter of mercury. So water is a solvent, so this becomes here Pa naught. Vapor pressure of solvent at 20 degrees Celsius is 17.5, and lowering of vapor pressure, so lowering of vapor pressure is Pa naught minus Pa. So lowering of vapor pressure of sugar solution is 0.061. Calculate relative lowering of vapor pressure and vapor pressure of solution. So we will write down the given. So vapor pressure, so if you look this one again, vapor pressure of water at 20 degrees Celsius is 17.5. So since water is a solvent, so vapor pressure of a solvent is Pa naught, which is 17.5 mm of Hg. And then lowering of vapor pressure of sugar solution, lowering of vapor pressure is Pa naught minus Pa, which is 0.061. So this becomes your lowering of vapor pressure. So Pa naught minus Pa is 0.061. So which is lowering of vapor pressure. Lowering of vapor pressure is Pa naught minus Pa. So what is the first question we have? Calculate relative lowering of vapor pressure. So you are supposed to calculate relative lowering of vapor pressure. So relative lowering of vapor pressure is Pa naught minus Pa divided by Pa naught. So relative lowering of vapor pressure is Pa naught minus Pa divided by Pa naught. So if I just put the values, I will have Pa naught minus Pa is 0.061 divided by 17.5. So if you divide these values, you will have 0.00348. So this will be your first answer. Relative lowering of vapor pressure, if you just divide these values with 17.5, you'll have 0.00348. And then the second part of the question is vapor pressure of solution. So vapor pressure of a solution is given by, I'll just write P as vapor pressure of a solution. So P is equal to vapor pressure of pure solvent minus lowering of vapor pressure. So vapor pressure of solution is vapor pressure of a pure solvent minus lowering of vapor pressure. So vapor pressure of a pure solvent is 17.5 minus 0.061. So if you subtract these values, you will have 17.439 mm of Hg. So this is how you can calculate vapor pressure of a solution when vapor pressure of a pure solvent and lowering of vapor pressure is given. This is how you can calculate relative lowering of vapor pressure and vapor pressure of solution when vapor pressure of pure solvent is given as well as lowering of vapor pressure is given. So now we have a new formula, which is Pa naught minus Pa divided by Pa naught is equal to Wb MA WA MB. So this is the new formula which we have and which we are going to use. PA naught minus PA divided by PA naught is equal to WB MA WA MB, where WA is weight of solvent, where WA is weight of solvent, WB is weight of solute, MA is molecular mass of solvent, and MB is molecular mass of solutes. So these are the terms we need to keep in mind. And PA is vapor pressure of solution, and PA naught is vapor pressure of pure solvent. I hope you know what is solute and what is solvent. So these are the terms. WA is weight of a solvent, WB is weight of a solute, MA is molecular mass of a solvent, and MB is molecular mass of a solute. PA is vapor pressure of a solution, PA naught is vapor pressure of a pure solvent. So if you just look the first question we have, vapor pressure of pure benzene at certain temperature is 262 bar. So vapor pressure of a pure benzene, so it is written pure benzene, and benzene is a solvent. Vapor pressure of a pure benzene at certain temperature is 262 bar. So this becomes here, so I'll just write the given out here. Since it is written pure benzene, so it will be PA naught, which is 262 bar. So we have pure benzene at certain temperature is 262 bar. At the same temperature, the vapor pressure of the solution. So at the same temperature, the vapor pressure of the solution containing 2 gram of non-volatile non-electrolyte solid in 100 gram of benzene. So out here, 2 gram of non-volatile solute is added in 100 gram of solvent. So a simple example out here I can give you is a sugar and a tea. So the tea become your solvent, and the sugar which I'm going to add becomes your solute. So in simple way, if you look on the same pattern, if you look this one, 2 gram of sugar I'm adding in 100 gram of tea. Okay, it's just an example. So this becomes your solute and this becomes your solvent. So I'm adding 2 gram in 100 gram of benzene. Or other way I can tell you is, if 2 grams are given, okay, just a trick, if 2 grams are given, the first gram becomes your WB and the second gram becomes your WA. So this becomes your WB and this becomes your WA. So I can write WB is equal to 2 gram, WA is equal to 100 gram. Remember, this will be your solute and this becomes your solvent. Since it is given in gram, it becomes the weight. So weight of a solvent is WA, weight of a solute is WB. Since this is the solute, so this will be WB, this will be WA. So at the same temperature, the vapor pressure of a solution containing 2 gram of non-volatile solute in 100 gram of benzene is 256 bar. So it means that the vapor pressure of a solution is 256 bar. So I can write PA is equal to 256 bar. So what is the question asking you? Calculate the molecular mass of the solid. So it's asking you to calculate the molecular mass of the solid. So what becomes your molecular mass of the solid? It becomes WB, MB, sorry. MB becomes your molecular mass of the solid. So this becomes your question mark out here, because the solid we are adding in a solvent. So I hope you know how to take out the given. So I'll just repeat once more. The vapor pressure of a pure benzene at certain temperature is. So out here this is given in bar and this is also given in bar. This is given in gram and this is given in gram. So simple way, if this becomes PA naught, this will become your PA for sure. And if this becomes your WB, this will become WA. So since it is written out here pure and benzene is a solvent, so this becomes your PA naught. At the same temperature, the vapor pressure of a solution containing 2 gram in 100 gram. So 2 gram you're adding in 100 gram. So this becomes your solute and this becomes your solvent. So this will be WB, this will be WA, and vapor pressure of a solution is 256 bar. So now we will calculate MB. So what will be MA? Since what is the solvent out here? The solvent is benzene. So what is the molecular formula of a benzene? C6H6. So this is the molecular formula of a benzene. So now we will calculate the molecular mass. So what is the atomic mass of a carbon? Atomic mass of carbon is 12 multiplied by, since there is 6 carbons, so I'll multiply with 12 plus atomic mass of hydrogen is 1 multiplied with 6. So you need the atomic mass, not the atomic number. And always remember, for some elements, if you multiply the atomic number with 2, you can get the atomic mass. So the atomic mass of benzene is 78. So this way you can calculate MA. Since it is not given in the questions, you can calculate this way. So now we have the formula PA naught minus PA divided by PA naught is equal to WB MA WA MB. So now I need to rearrange the formula. So I need to calculate MB out here. So MB is equals to WB MA divided by WA. This will come down out here, multiplied by PA naught minus PA divided by PA naught. I'll just put this one in a bracket better way. So remember, this one can go upside out here. So if I just write it out here again, so I can rewrite the formula again. So WB multiplied by MA WA multiplied by PA naught minus PA. Since this is on the lower side, this can go up here. So I can write PA naught. So now I will put all the values. WB is 2 multiplied by MA is 78, PA naught is 262, WA is 100, and then PA naught 262 minus 256. So if I multiply all these values out here, I will have 40872. And then if I multiply these numbers, first I will subtract this number and then I'll multiply with 100, then I will have 600. So if you subtract this number, you will have 6, and 6 multiplied with 100 is 600. You shall have 68.12 gram per mole, since it's a molecular mass. So this will be the molecular mass of the solid, 68.12 gram per mole. So this is how you can calculate the molecular mass of the solute. I hope you understand each and every steps. All these are simple multiplication. You multiply the numbers, you will get these values. You subtract the number and then multiply with 100, you will get these values. You divide these values with 600, then you get 68.12 gram per mole. So now again we will try the same type of equation again. So here is the equation. The vapor pressure of water at 293 Kelvin is 0.0231 bar, and the vapor pressure of a solution of 108.24 gram of a compound in 1000 gram of water. So 108.24 gram is added in 1000 gram of water. So again, this gram and this is also gram. So what did I say previously? The first gram which is given will be WB and the second gram will be WA. So if you don't want to understand in that way, always remember we always add a solute in a solvent. So this becomes your solute and this becomes the solvent. So solute, weight of a solute is WB and weight of a solvent is WA. So I'll just write the given first. So WB is 108.24 gram and WA is 1000 gram. So this is given in the equation. So vapor pressure of water, always remember water is a solvent. So vapor pressure of water at 293 Kelvin is 0.0231 bar. So now this is also a bar and out here also we have a bar. So there is 2 bars. So since this is vapor pressure of water and water is a solvent, so you have PA naught is 0.0231 bar. So this becomes your vapor pressure of a pure solvent. And the vapor pressure of a solution of vapor pressure of a solution of these things. Vapor pressure of a solution is 0.0228 bar. So PA vapor pressure of solution is 0.0228 bar. So this becomes, since this is your pure solvent, this becomes your solution. So it is quite easy. Calculate the molar mass of a solute. So you're supposed to calculate the molecular mass of the solute, which is MB. So you're supposed to calculate MB. So now is MA given? No, MA is not given. So but what is solvent out here? Solvent is water in 100 gram of water, right? So water is the solvent. So we can calculate the molecular mass. So Ma, which is water. So I'll just write H2O. So now we need to calculate the atomic mass of water, atomic mass of hydrogen and oxygen. This way we will calculate the molecular mass. So atomic mass of hydrogen is 1. Since there is 2 hydrogen, you multiply with 2 plus oxygen. Oxygen atomic number is 8. So if you multiply with 2, you get 16. As I've told you earlier, for some element, if you multiply the atomic number with 2, you can get the atomic mass. So atomic mass of oxygen is 16. So you'll have 2 plus 16. So you'll have 18 gram per mole. I can just write gram per mole. So the atomic mass, the molecular mass of water is 18. So Ma is 18. So Ma is not given in the equation. You need to calculate it by yourself. You need to know, you need to see which one is the solvent. Since solvent is water out here, you can calculate the molecular mass of water. So if you don't want to calculate also, just remember molecular mass of water is always 18, 18. So now what is the formula? We have Pa0 minus Pa divided by Pa0 is equal to Wb Ma Wa Mb. Just the opposite. If there is B out here, there is A. If there is A out here, there is B. If there is B, Wb is upside, Wa will be on the lower side. If Ma is on the upper side, Mb will be on the lower side. Easy way to remember the formula. So now since you're supposed to calculate Mb, I'll just rewrite the formula again. Wb Ma Wa Pa0 minus Pa divided by Pa0. So this Pa0 can go up here. So Mb is equal to Wb multiplied by Ma multiplied by Pa0, Wa multiplied by Pa0 minus Pa. So I can write in this way as well. So I'll just write down the values. Mb, so what is Wb is 108.24 multiplied by Ma is 18 into Pa0 is 0.0231, and then Wa is 1000 multiplied by Pa0 0.0231 minus 0.0228. So Mb is equal to 108.24 multiplied by 18 multiplied by 0.0231, and then you have 1000 into, if you subtract these values, you shall have 0.0008. So 0.003. You shall have 0.003. So if you calculate the values, so easy way to do is you remove all the points and then you can do the cancellation. That way also you can get the answer easily. You remove the points and then you can do it. So I'll just do it for you. 10824, this is how you're going to remove the points. 18231, 1000 out here, and then out here 3. So after the point I have 1 2 3 4, 4 digits. So upside I will put 4 zeros. 1 2 3 4. Since after the point I have 1 2 3 4, 4 digits, so I'll put point on the upper part. 1 2 3 4, 4 zeros. And out here after the point I have 1 2 3 4 5 6. 1 2 3 4 5 6. So I'll put here 6 zeros. 1 2 3 6 zeros. So this way all the points are removed. So you say 1 2 3 4. You can just cancel, and then you can do the cancellation and then divide, and then you will have, so if you calculate these values, you shall have 150. So this will be your answer. So the molecular mass will be 150, molecular mass of the solute. So this is how you're going to calculate the molecular mass of the solute. So now we shall solve the next question. An aqueous solution of glucose is made by dissolving, a solution is made by dissolving 10 gram of glucose in 90 gram of water. So in 90 gram of water, you're adding 10 gram of glucose. So this becomes your solute and this becomes your solvent. So you're adding a solute in a solvent. So I'll just write the given WB, which is a glucose, that is 10 gram, WA is 90 gram. So these are the two given. If the vapor pressure of a pure water, so water is a solvent, pure water, pure solvent, at 303 Kelvin be 32.8. So it's very obvious it will be PA naught, which is 32.8 mmHg. What would be the vapor pressure of solution? So vapor pressure of a solution, which is PA. So you're supposed to calculate PA out here. So now they haven't given you MA and MB, but we need to look at the question properly and then find out MA and MB. So 10 gram of glucose. So glucose is a solute, which is WB. So MB, which is a glucose, you have C6H12O6. So now we shall calculate for glucose. Carbon, atomic mass of carbon is 12, since there is 6, 1 into 12, since there is 12 hydrogen, and atomic mass of oxygen is 16 into 6, since there are 6. So you have 72 plus 12 plus 96. So you'll have 180. So the molecular mass of glucose is 180. And then what about the solvent in 90 gram of water? So water is your solvent. So since for MA, since it is water, and as we have already calculated for water, water is 18. So these are the givens from the equation. So now we shall calculate PA. So what is the formula? PA naught minus PA divided by PA naught is equal to WB MA WA MB. So since we're supposed to calculate this one, so what I will do is I will move this one out here, cross multiplication. So I can write PA naught minus PA is equal to WB MA PA naught WA MB. So I will write down the values now. What is PA naught? We have 32.8 minus PA, and WB is 10, MA is 18, PA naught is 32.8, WA is 90, MB is 180. So 32.8 minus PA. So if I multiply these values, I 5904, and then if I multiply these values, we'll have 16200. 16200. So now I will divide these values. First of all, 32.8 minus PA. If I divide these values, I shall have 0.364. 0.364. So what will be PA? Since out here it is minus PA, I need to make it to plus PA. So what I will do is this minus PA, I'll move this side, and these values I will move this side. I'll just change their place. So minus PA, if I move on the right hand side, it will be plus PA. So I'll have 32.8. If this one comes this side, it will be minus 0.364 equals to, we go this side, it will be PA. So I can write this way: PA is equal to 32.8 minus 0.364. So you'll have, so if you subtract these values, you'll have 32.43 millimeter Hg. So it will be around 32.44 or 32.43 millimeter mercury. So this way you can calculate vapor pressure of solution. So these things, if you don't want to multiply, you can use the log table. With the log table, you find the values. Again, you take anti-log and then you can write down the values. That way also you can do it. Or else you multiply, you cancel the values, and then you'll get these values. So the calculation is quite easy. I hope you understand each and every problems that I'm solving. And if you have any issue while solving the problems, you may please write down your problems in the comment section. I'll be